remember, we said that before, this number is the atomic number or protons number inside the atoms, okay, inside the nucleus in the atoms. And we said that this number is very important because by this number the scientists will rearrange the all of the elements in the table, in this table in sequence or in order. Okay guys, now by this way they can rearrange the elements inside this table. This number is very important. Okay, now today inshallah we will talk about more property about each group of this periodic table. Okay, now let's start with the first group here. We said that guys, the numbers up here, these numbers also, this is the number of the group or column. Okay, that is the group number or column number. Okay, now this is the group number or column number. Just a minute guys, I'm sorry. Okay guys, now we said that this is the number of groups. Okay, now if you look over for the first group here, this first group is called alkali metals. Now that is the first group do we have in this table. You can see that these alkali metals in the first group. Okay, and these alkali metals, all the objects or most of the objects in this group will react like each other. Okay, the reaction with water, for example, like each other. If we take sodium, for example, sodium and potassium, both of them a very high reaction with water. Okay, they will explode it and make a lot of fire and make a lot of smoke get out. Why? Because this one will react very strong reaction with water. Okay, because the properties for both approximately the same. Okay, the property for both approximately the same, and this group is called alkali metals. Now I'm going to show you a video about the alkali metals and about the sodium, how the sodium react with water. But before oh, can you see that guys? It's real amazing. Now that is the very strong reaction in water. That is the sodium. This is the just piece of sodium. Okay. Now all the alkali metals, it will be the same reaction in water. Okay, all the alkali metals have the same reaction in water. Now as you see here, now we have approximately the same property with these. Okay, now I will change the this periodic table. I'm going to now show you another periodic table. It will be easier to understand and better in looking like. Okay, now look over guys here, that is the alkali metals in group 1. Okay, and also guys, in another kind of the reaction or the property also for alkali metals, that is react with the group number 17. The group number 17. Now alkali metals most of time will react with the group number 17, this group. Okay, and this group is called halogen group. Okay, now these elements in this group, fluorine, chlorine, bromine, iodine, all of them are called halogen. And most of time the alkali metals will react with halogen. Why? Because this one the same property and here also the same property. Listen to me guys, when I said same property, it not means all of them should to be in gas state or in the or the solid state or like that. Sometimes will be different in state. Okay, but I mean the chemical reaction. Okay, all of them will make the same chemical reaction. All of them will react with each other, strong reaction, very strong reaction. Okay, now watch this video about the sodium will make reaction with fluorine, chlorine, bromine, iodine, and it will be approximately the same reaction with all, with fire and smoke get out and very strong reaction like that. Watch this video.
Column 17 of the periodic table. Each element with their own unique personality. Chlorine, a gas. Bromine, a red liquid. Iodine, a metallic solid. Let's take a look at each of them.
Okay guys, now here this guy will make experiments when we have sodium from the alkali metals, or from the first group or first column, and this sodium, okay, will react with the halogens. Okay, now this is the formula for this equation. We have here sodium and chlorine. Inside this one we have chlorine gas. Can you see that, guys? That is sodium with chlorine. Very strong reaction, okay. The same thing will happen with the other halogens. Okay, amazing, guys. Okay, now with the bromine, now that is the bromine liquid. Okay, and by the way, guys, the bromine, it will be the liquid for nonmetals. All nonmetals, solid and gas, except bromine, the liquid in the room temperature. Except the bromine. Bromine will become liquid in the room temperature. Look over. That is the bromine, okay, and that is the sodium. Okay, can you see that exploding about the sodium with bromine? Look over. Can you see that? Very strong reaction. Oh, very strong reaction. Sodium with bromine. Okay. Oh, that's the reaction with the bromine. What about iodine? Okay, and also the iodine. We have here iodine, guys, because we have here iodine because iodine it will be something like gas, but it should be in the low temperature. Okay, and okay, now the sodium. Okay. Oh, also strong reaction. Can you see that? Strong reaction, iodine with the sodium. Okay, very strong reaction. Okay, and by this way, guys, you can see that all of this reaction with the first group here, that's called alkali metals, approximately the same reaction with all halogens here. Okay, by this way, you can understand that again. Now all groups have approximately the same property. All group, lithium, sodium, potassium, rubidium, cesium, francium, all of them approximately, hydrogen also, approximately the same chemical reaction. It means we are very close from each other from their properties. And also, guys, we have the last example for that. We have another example for that. Look over here for the last group we have here, group number 18. This group is called Nobel gases. Nobel gases. These noble gases rarely to exploding or to make reaction. Okay, mostly do not make reactions. Okay, this one, the most stable elements do we have for all schedule, and all of them are gases, as you see here. Now all of them have the same property. Do not make reaction. Okay, now the same property, guys. By this way, now all the elements in the group, in one group, will be approximately the same property. Okay, and even the row, but not all time. Okay, if you look over here for iron, cobalt, nickel, iron, cobalt, nickel, all of them will attracted by the magnet. Okay, if we have magnet, the magnet will attract all of them. Of course, all of you understand more about iron, because if you have any piece of iron, you can see that very easy and very simple. This iron will attracted to the magnet. Okay, the magnet can attract the iron very well, and I think most of you understand that. But what about cobalt? What about nickel? I think that's new for you, because that I bring video to look over how the magnet can attract the cobalt and nickel. Look over, guys. Okay, now in this video I'm gonna show you now some materials, cobalt, nickel, and make a lot of experiments and with using this really amazing, really strong magnet. Okay, guys, now this is the strong magnet, very strong magnet, and use different materials, cobalt, nickel, iron, and like that. Okay, but I make it faster because it takes a lot of time. Okay, now okay, guys, now as you see here, that is the three kind of elements, all of them have this magnet property, okay, attracted to the magnet. Okay, faster. Now that is cobalt, guys. Can you see that? That is the cobalt. Now this down here, that is the very strong magnet. That's the very strong magnet. Okay, that's cobalt. I think that's the first time to see the cobalt. So do I. Now that is the cobalt, guys. And cobalt should be in the low temperature, very low temperature. Okay, this is the cobalt. Can you see that? Oh, very strong attraction between the magnet and the cobalt. Now cobalt, nickel, and iron, all of them have the same property to exert it to the magnet. Okay, let me to ask you a question, very important. In last session we said that all the elements made up of atoms, and each atom have the same property of all material or all the elements. For example, if we have gold, now that is gold. If we take very small piece of gold and go to the microscopic, very high microscopic level, and take just one atom of gold, it will be the same property for both. The same property for both. Gold like the atom of gold. Okay? That's clear? Yeah, both of them that's the same. That's the element. That is the element. It will be like that. All elements like that. Okay? Except the carbon. If you look over for the carbon, guys, you can see that we have different kinds of carbon. Okay, we have diamond, we have coal. If you look over in your book, okay, page 435. Okay, we have here coal, graphite on the pencil, and diamond. Of course, diamond very expensive, and you can't find it in anywhere, and like that, guys. Okay, coal very cheap. You can find under the ground and anywhere and like that. And I think you understand very well what is the difference between coal and diamond. The question is, do you know both of them made up of carbon? Yeah, both of them made up of carbon. The question is, how they both of them made up of carbon, and this one it will be diamond. Of course, you know what is a diamond. And this one boar shape, and this one very boar. Now this one ugly and boar shape and like that. This one made up of carbon also. How? Anyone have an idea, guys? As you see here, this is the periodic table, and that is the carbon here. Can you see that? That is the carbon, okay, with 6 atomic number. Okay, now this is the carbon, and that is the diamond and graphite and the coal and like that. These are the different kinds of the carbon under the ground. If you look over here, guys, can you see this crystal structure? Crystal structure. That's the crystal structure for diamond and the crystal structure of graphite. Now, because of the atoms arrangement, because of the atom arrangement, we have different kinds of carbon like that. Okay, now the atoms arrangement, and this not happen in normal case. It's happen under the surface of the earth by the very high temperature and pressure and like that. Okay, and when we have all of these things, sometimes we can find this diamond. Okay, again, because of the crystal structure. If you look over for diamond, for example, the diamond structure to be like that. That is the atom of carbon. That is the atom of carbon. Okay, that is the atom of carbon. It will be look like that, guys. Okay, okay. Now this is the arrange of the of this atom with each other. But in other hand, the graphite it will be like that. Different in arrangement. Different in arrangement. Okay, guys. That is the difference, guys. That is the difference between graphite and diamond because of the crystal structure or arrange of these atoms with each other. Okay, because of the crystal structure. Because of the crystal structure, all properties will change. This diamond will be like that, and the coal will be like that. Okay, at the end, I hope you understand, and I hope you enjoy this session with me. Thanks a lot. See you next time, inshallah. Rabbil Alameen. Assalamu alaikum wa rahmatullahi wa barakatuh. Goodbye.